Hi dear students, welcome to S4 Sharanya Science classes. Today we are going to discuss about the reaction of metals with other metallic solutions, right? So you can see here metal reaction with solutions of other metals. What type of reaction it will show? Here you have to remember that we have discussed about metal with reaction with oxygen, reaction with water and reaction with acids also, right? This is the last topic of that chemical properties of metals, the reaction with other solutions of other metals, right? So the reaction of metals with the solution of other metals, how the reaction will be there? Obviously it's a single displacement reaction, you can easily understand, right? How? More reactive metal here if you are taking, then if in that it can displace the less reactive metal from the salt solution of other, right? So you can see here if you are taking a more reactive metal, right? For example iron, and you are taking a other metallic solution, right? So you can see that copper sulfate, which is a metallic solution, right? So if it is more reactive, then it can displace, right, this metal, copper metal, which is less reactive than iron from the salt solution, right? Here you can see that what forming, just taking the place of that copper, right? FeSO4 and this, so you will be displaced. So this is a single displacement reaction we have learned in chapter 1, right? So here generally we can say that if you are taking a metal A and salt solution of metal B, then you will get salt solution of metal A and plus metal B will be displaced. So it's a single displacement reaction. So easily you can remember that. What is the reaction of metals with acid? It's a single displacement reaction. How? More reactive metal will displace the less reactive metal from the salt solution. That's only you have to say. It's a single displacement reaction. What will be the general equation? If you are taking a metal A which is more reactive and salt solution of metal B, right, which is less reactive metal, then it will be, you will get salt solution of metal A and metal B will be displaced. So I have taken an example, iron plus copper sulfate, CuSO4, you will get FeSO4 plus copper. What is, how can, if it is that now in practically if you are doing, what will be the observation? Iron, if you are putting, right, if you are taking a beaker in which you are taking copper sulfate solution, right, which is blue in color, right? Copper sulfate otherwise known as blue vitriol, right? Blue in color. If you are putting a iron nail into it, a fresh iron nail, right? After some time, after half an hour or 1 hour, if you are watching that, you can see that the observation will be like this. This beaker, the solution will turn to green, right? And you can see that there will be copper color coating on that iron nail. There will be a copper color coating on the iron nail. What is the reaction? Reaction is single displacement reaction. Why? Because iron is a more reactive metal and you are putting in a salt solution of that less reactive metal. That's actually copper sulfate. Then obviously single displacement will be there. This iron will take that place of that copper and you will get that ferrous sulfate solution which is green in color, and this copper which is displaced will be forming a coating on the iron nail. This will be the observation. So in both level you can expect the questions either in the color changing reaction or as such the metal react with that solution of other metals, like that also you can expect. Even single displacement reaction directly they will ask that what you mean by single displacement reaction and given one example, like that also the questions we can expect, right? If we are taking, right, copper metal and ferrous sulfate solution, what will be the reaction? Copper and ferrous sulfate. So what will be the reaction? Can you say? Obviously single displacement must be there, but it will not show any reaction. That means there will be no reaction. Why we are saying no reaction? Because it's a less reactive metal. Less reactive metal cannot displace more reactive metal from the salt solution. It must be a more reactive, high reactive metal, then only it can displace the less reactive. So here there will be no reaction because copper is less reactive than iron. Always remember it must be a high reactive metal, then only it can displace the less reactive metal. How can you understand that whether it is high reactive and more reactive? We learned that in the class 10 chapter 1 itself, the reactivity series, right? So here in this chapter we are again going to refresh about that reactivity series. Those who don't know about this, please go through that. It's very helpful for you for understanding that reactivity of different metals, and also it is helping for you to understand the single displacement or double displacement reactions very easily. Right. So here we are going to learn about the reactivity series. What do you mean by reactivity series? Right. So reactivity series, it's a list of common metals, right, arranged in the decreasing order of their reactivity. Arranged in the decreasing order of their reactivity. I will write it, please go through that. You can see. Sorry, here it's not that much space, so I am shifting here. Yes, this is the reactivity series. Look at here. Look at here, this is the reactivity series. Right? You can see here, this is the reactivity series. How to learn this? There is a method of learning that also I will tell now. You can follow any of the method, there is no problem. This is my method. I am following this technique, right? So, K, potassium, right? NaCamG, K, NaCamG, alzan, phenicin, PB, HQ, HGRG, IUPT. So it is a very easy method to learn. K, NaCamG, alzan, phenicin, PB, HQ, HGRG, IUPT. So you can learn that reactivities very easily. So that you will remember that, and from this you will understand how the reactivity is. I will explain once again. Here you can see that this is a sodium, which is a highly reactive metal, high reactive. When you are coming down the series, the reactivity decreases. We told that it is a list of common metal arranged in the order of decreasing reactivity. So in the topmost you can see that which is highly reactive. When you are coming down, you can see that the reactivity decreases. Here you can see a non-metal is there, hydrogen, right? It's for the separation. Above hydrogen they are actually highly reactive, we can say that, more reactive, right? And below hydrogen reactivity very less, right? So here you can see that if you are comparing, right, from the higher topmost, they are highly reactive, then that reactivity decreases, then these are the least reactive. Last you can see that IUPT. What is that IU, right? AU, gold and platinum, right? Here potassium, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, nickel, tin, lead, hydrogen, copper, mercury, silver, gold and platinum, right? So you can see that the reactivity decreases. So above hydrogen, whatever the metal, they can easily displace the below hydrogen metals. So that's why here you can see that if if you are getting such reaction, just check that. If you don't know what to write here, right, just check where is that ion. First you write that reactivity series, you return down and you check that where is the position, right? Check that ion. Yes, ion is here. What is the position of copper? Copper down. Obviously from a highly reactive they can displace the low reactive. Now here you can check that copper and iron sulfate. Copper, it is actually lower side and iron upper side. Obviously they cannot be displaced. So easily you can remember that. So reactivity series, if you are learning, you can go for that single displacement reaction very easily. If I am giving another solution, for example Zn plus CuSO4, what will be the reaction? Can you say it is single displacement reaction will occur or not? Here you can see that, check the position, zinc, right, copper, obviously lower side, it can displace. So here ZnSO4 plus Cu. If I am taking Cu plus ZnSO4, obviously that's now opposite, you can take that. If I am taking Zn plus FeSO4, this reaction is possible, obviously possible, because zinc upside of that iron, whether one portion, whatever it is, they are highly reactive than that ion. So there will be single displacement reaction, it can displace. So what will be the reaction? ZnSO4 plus Fe. So this is the easiness. If you are learning that reactivity series, it will be very easy. Once again I am telling the technique. K nakam G, alzan, phenicin, Pb, HQ, HgRg, IUPT, right? Maybe you will feel funny, but it's an easy method, you can easily remember that. You can follow any of the method, but this reactivity series must be learned, then all the reaction will be very easy to understand. Thank you.